All right, guys, time to start. So first of all, warm welcome to all of you. I think some of you already started today and continued also with the evening. Some familiar faces from prior meetups, so nice to see you back again. And of course, Kathy and Seth, it's really great that you're here, and yeah, fantastic that we had this opportunity. So quite quickly through the agenda. It's not a very special one, as you can see. Willem will do a talk, Seth will do a talk, and I will kick off with a small talk. And then we have some networking and drinks. The code of conduct is there. You've seen it already, so please be nice to each other. And you can read what we would like to have. And yeah, I would like to start with a demo. And with all demos, this is a real demo, so things can go wrong. But I prefer to share you even my mistakes or things that don't work perfectly instead of just giving you screenshots, which is not the real world, right? You can find all the materials on the Global AI community site. We have the learning materials part. There you can find the GitHub repository, so you can do it by yourself whenever you want. And for today, we have a case around the performance of an employee. So we're in the HR analytics space. Imagine you're an HR manager. You have a lot of information about your employees, but instead of doing, right, you'd like to develop a solution where you sort of get, you can maybe also do some interventions. Now, for now, of course, it's just a demo. So yes, you can, bug me with all kind of things. However, I would like to inspire you, say, right, this is something we could do. And if you look at your employees, you can think of many things, right? You're not working alone normally, so you're in a team as a manager, and of course, there are all kind of characteristics about age, gender, position, if you're satisfied, if you do nice projects, etc., etc. This is just to give you an idea. And this guy, Rich Hubner, has created a data set around HR analytics, because there was one, it was on Kaggle. Maybe some of you already found it in the blog I published years earlier, but they retired it, so it's like, okay, what to do next? And luckily, he was willing to make his data set public. It was just in Kaggle before, only on Kaggle, but I asked him, he said, yeah, I want to do that. I will put it on GitHub so everyone can use it. So actually, big thanks to this guy, although he's not here, for sharing his file. It's simulated data, and he's really open for feedback. So if you, after this night, you think, hey, I would like to do this, please approach him, reach out, tell him what you think, because he really likes it. All right, so we have a demo. Now, first of all, data is never perfect, so we will do a little cleaning. I will just show you. And then we will use the new interface actually around Microsoft Azure Machine Learning Services. And at the end, it's really nice that you have a model, but I got really happy with JSON. Now my customers are not very happy with JSON or whatever output. So hopefully we'll come to the end where we can also show you the final results in the Power BI. All right? Is there anyone time managing? Because then Willem, could you do that task? Perfectly. All right, let's get started then. All right, and we will also do it following actually the data science lifecycle. So we start with our problem. Let's say, hey, we want to know about our employee performance. How are they doing? We would like to understand it better. And of course, we're going to cross things. So we have to get the data. We have to get a first understanding. We have to explore it a little bit, maybe create some features, model it, deploy it, and at the end, make something where our fictitious customer is happy with, right? Okay. So we start with getting the data. And in this case, as said, I got you everything on GitHub. So if you go to this repository, that's still findable, you will find a file which collects the data, and we get some quick information about it. So This is just, we need some libraries to work our data through. I used R, but you can build it in Python too, of course, or C#. And we first would like to understand the data we have. So what's in it? Well, in this case, he gathered data around the gender, but also race, the age, if people terminated or not, if they're happy, what their manager was, etc., etc. You can walk through this later on. And he also provided, after asking, for a data dictionary. So one of the things, of course, when you work with data, you would like to understand actually what the variables do. I'm from the social sciences space, and I know social sciences in one phrase is a bit weird, but we sort of try. So in our case, you would like to understand where you're talking about. So actually, you have an explanation for every field instead of variable x to n. And after that, you can also have a quick inspect of your data. So you can inspect it quickly, and we see, well, we miss a lot of things. We see some weird things, like, let me see if I can show you quickly. We had something with, it's always hard to see. Oh, yeah, here we go. So, yes. For example, little things like, hey, we got information about if somebody's Hispanic or not, and then we have things like, all right, we got no and yes, but hey, some of them use capitals, other lower cases. You know, the basic things you encounter where you drag whatever data set. So you start cleaning, and you say, well, first of all, let's get some names consistencies. And we want to filter because, yeah, we're talking about the people. So if they don't have a name or an employee number, we're not going to use them for now. And actually, they also need a review. So we have something to train a model with. And then we do some quick inspections and so forth and so forth. And we can start visualizing our data. So if it comes to the performance, we actually have only 4 options in this case. We can exceed performance. A lot of them really meet the performance. Some need improvement. And I think that's a personal improvement plan or something. So basically, in this data set, a lot of them fully meet the expectation. Now that's also already sort of setting the scene. And yeah, it's sample data, so this is what it is for now. Of course, in real life, this might be a little different distribution. And we can also look at things like, all right, if we talk about, for example, gender, is there a lot of difference? Now, instead of running, let's say, just a statistical test, we can also visualize it by, well, there's not so much difference in gender, right? If you look at this, quite same. But we also have department information. And if we look at the department information, we do see there's a difference, right? We see that the executive office, well, it's quite high, but also the admin offices, quite high. And here in software engineering, something is at least different. So we have some variation, which is also nice, because if you don't have variation, all right, then what would like to train? Interesting fact, we have information by manager. Well, there's quite some difference here. So that triggered me, at least for this demo, to say, all right, we're also going to work with team data. Because we know that the different teams, assuming that people work for a manager, form one team, so that's just an assumption, they have very different scores. So let's take that into account. And this is an example of, all right, we have an idea, we know something, but hopefully about HR analytics. So what could we do with this data? Now, for example, we can calculate the age of somebody, because we know that age might influence your performance, maybe based on the other obligations you have regarding your household, your partner, etc. It might depend if you're single or not, right? So let's take age into account. So we can calculate that one. And another one is tenure. Are you just a newbie at the moment of review, or do you have already several years in the company? So tenure is the second one we create. And then another one, as said, we have seen a lot of differences regarding the team information. So there is a theory. I'm not going to bug you with a lot of theory, but that's the fault line theory. Let's say it's in the diversity space, where you're not looking only at one variable, but you're looking at the distribution, let's say, regarding several variables. So in our case, it's not only, for example, gender, but we also look at somebody's age, somebody's race, like ethnicity, and somebody's pay rate, because maybe that could trigger some differences. So instead of just looking at one variable, you look at many of them, and you actually get a score out of it. So it's sort of a risk score. Like if it's very high, a team might divide up into 2 or 3 or even more subgroups, and that's not always good for performance. It depends, but at least it has some influence. So we do that too. We create a nice, it's called a fault line score. We calculate it. We calculate the fault line score for every team. So what's the risk of that they could split out into several teams? And we see, for example, one manager only has 2 people. Well, then you cannot do the calculation. So it's sort of like, well, I mean, then you're just 2 individuals and you're not a group anymore. And we add everything. All right, then we add everything and we store our data. And actually now we're ready to start with Azure, because now we did set, let's say, the cleaning. We also made a validation set for now, so at the end we can use our model with the validation set, and we have a training set. So here we save the validation, well, and we have the training. So now we've done that, we can start with actually the training of the model. And for that I want to show you the new interface. Who've seen this one? Yeah, I see some. Okay, good, nice. Looking forward to hearing your feedback also. But one of the things is that you can upload a data set. So that's what we're actually going to do. And the nice thing is that you can also inspect the data quite quickly. So we're going to create it. For now, I just take a local file. Of course, you could also get it from Azure directly. And I take my, let's say, newly created data set from our PBNN. And you can say, all right, I want to give it a name. So today it's, let's say, 3009. It's tabular. You can give it a description. And you can start with your inspection. So, it's good. Nice thing also that now you can use a delimiter. I know for many Dutch people that was also always a problem because Azure required commas and Dutch people used a semicolon. Now you can use it, you can change it actually. So that's good. Well, it already recognizes that we have a header, so nothing to do there. And as you can see, it even recognizes things like dates, right? It's already pre-formatted. And here we see our also, you know, our full line score, it's everything there. So we can go to the next step. And that's actually, all right, which data would you like to include? Well, in this case, I don't need, for example, an employee's name. Maybe you don't want to store that sensitive data in this data set, just an ID is fine. I have a marriage description, so the ID is not necessary, so just skipping out a few here. If you read through the description, you know what to eliminate and what not. I do want to know where they come from. Pay rate's interesting. Termination, not yet. The position is nice. Where do they live? That also gives you some socioeconomic status. Date of birth, we're not going to use that because we used their age. And then we got their gender and description. This is also fine. Date of hire is not necessary anymore because we got tenure, so we know how long they're working for us. Date of termination, also not for now. Their status is either active, because you can even see it what it is. So they're all active, we don't want that. Manager ID is not because we use the name. In this case, because the ID was missing for some. And then actually, if they did last special projects, also interesting. And the review date is not necessary anymore. We know that when this was the days where they were late in the last 3 days, we inspected it already, and everything is 0. So it's it's just a continuous variable or just a constant. We don't need it. All right. So basically, we are there, and yeah, it's just new. So I have to flip a little bit back. That will be fixed, I think. And you can say, all right, we're done. And there it's creating the data set. Yeah, and there it is. So good news. Now we can start training the model. And for this case, I use the automated ML. And yeah, I played already a little bit with it in this in my research group. So you got an overview of what you've done, what worked, what didn't work, and other things. And here you can also select them. That's what we do afterwards, because I'm not going to let you wait for 20 minutes to train it, but just showing you how you could do it. Now we have the data, so we can create it, and we call it HR, let's say 3009. And you need a compute. That's fine. I already created one, but if you don't have a compute, you can create it here also. And then there's the next step. And we're going to select our newly uploaded data set. And the good news is that you can use profiling. If you have a compute with at least one node, you can also see your data. So you can inspect it. So if you look at the managers, for example, you see the ID is not so interesting. But for example, if people come from a diversity job fair or not, you see the distribution of the pay rate. You also get information around if you're the count, so how many observations do you have? Are you missing things? Minimum, maximum, etc., etc. So it gives you a quick impression. Already you did it, but it's nice to have some insights. So you got a preview, and now if we want to train a model, we have to maybe eliminate some information. For example, we don't want the employee ID because that's an identifier. So, but furthermore, we're actually quite okay. So, and at the end, yeah, we got our performance score. That's our dependent variable. That should be in here, of course. So basically, by just eliminating the employee number, we're fine. And we have a classification task because, as you remember, we had 4 categories, right? So we are in the classification space. And our target is our performance. So here we go. We got the performance score. And then you have some advanced settings. So you can choose on what you're training. So do you want to be accurate, right? Or do you have other metrics to train the model on? Now the good thing is it's a primary metric, but when you've trained the model, you will also get all the other metrics. But for now, well, we're fine. We want to be accurate. So we want to know for every single class what they would do or not. Here you can choose how many minutes the job will train. Well, for now, let's say 10 minutes, but as said, I will continue with another model we already have and not let you wait. And you have a lot of options here. Like, for example, the whole pre-processing part, that's literally a tick in the box right now. Okay, so that's really nice. You can also say number of cross-validations. Well, for now, it's fine. And you could exclude also algorithms, but we're not going to exclude anything. So basically, it's just hit start and you go. So now it will create, it will spin up everything, it will run. And of course, I'm not going to let you wait for 10 minutes and a little bit to get it started. So we'll go back with the results from a model I trained yesterday. So if we come, you say it's preparing here, but this one is completed. And this is what you get. So the nice thing, what it does, we say, all right, just use a set of algorithms based on the fact that we're in the classification space. You get all the cores and the time it runs and find the optimum. So instead of looking for the optimum yourself, it's finding the optimum. And at the end, it comes up with the best score. So it could be, for example, the first run was actually quite okay. But in the 11th iteration of it, that was at the end the algorithm that did the job, or the model that did the job. So what you can then do is say, all right, you see all the different scores, right? That's my best metric, is the red line. And when it's ready, you can say, all right, deploy it. Or you can download it. So the nice thing also, you can deploy to every device you want, actually. You can download the pickle file, then you're also happy. You can do whatever you want with it. But for now, we just deployed it. So there it is. You can also click on it, actually. You get some more insights. You get all kind of metrics. You get also the other metrics. As I said, for example, we selected the accuracy score. But as you can see, there are a lot of other variables and KPIs you could use. Now, we also have to be honest, because at the end, if you look at this model, well, 70% 7% accuracy. If you remember the bar charts where you saw like the fully meet, right? Yeah, let's be honest. I mean, we already knew that more or less. And if you look at the confusion matrix, you also see that the model is pretty good in predicting fooling meets. But yeah, that's also sort of a demo for sake of a demo. That's like, okay, good. We know that, but it's also the idea that it can do it. It also gives you the information, so you can decide for yourself whether you would need to do something else. But for now, for demo's sake, we're good to go. So the good thing is we've deployed it. Right, so if we look at the models, this was the one yesterday, it's there, and now we can use it. Because remember, when we cleaned the data, we set also a little bit of data apart. And now, of course, you want to use this model, right? I mean, it's a nice model, but hey, what are we going to do with it? And the nice thing is that you can use Power BI nowadays to invoke your model. So no heavy coding. It's basically, I already got it open. Oh, shit. It's basically creating a new flow, connected to your model, and use it in your normal Power BI reports. So for that, we're going to the workspace. Let me see. I'll go to a data flow. Yes, please, today. Don't save. Good. All right. So we're going to make a new flow. And we're going to use the validation set to connect it to the model. And then we can basically then run it in Power BI. So we create a new one. And we add a new entity. One step I forgot, I uploaded also the validation set to Azure. So it's in a blob storage. And let me see if this can find my session. No. But hey, here we go. Good. The nice thing actually when you create a workspace is that it creates also storage for you. So here we got a storage. And there we go. So we need an access key in this case. Please don't make copies of that. But hey, it's fine. So we're going to select the file. And I uploaded it to the data blob. There's my container. And there it is. We see the validation. There you go. Yeah. Fingers crossed that it does import it. Yes. Good. Phew. Good, that's there. So this is our small validation set that we saved apart to run the model with. And as you can see, we got here the manager name, etc., etc. But we don't have our performance score here, right? Of course, we removed that because this is a validation set. So it's not there. Okay, so now how do we get it? Well, we have here a nice option. We got AI Insights. So if we use this one, we have the option to use our deployed models. A little bit of patience. I still have 4 minutes, so I think we're doing fine. And I take the model from yesterday. So this is the model I trained. And the good thing is what it will do, it will map the information in your file with the required values, actually, so with the required variables. So basically, it's already pre-formatted because everything, in this case, everything matches, right? If not, if, for example, your file has a different naming, then you can select it here and you can assign it. But in this case, as every variable name is unique and it's the same, it will detect it, so you can say apply. And yeah, we got a warning, but that's good. And now at the end, it adds the prediction. All right, so now you're actually good to go. And because these are things you can, of course, schedule. So now it's just, let's say, one little validation step, but imagine you have running data, right? There's coming data in over time. So you can schedule that. All right, so we're saving it. All right.
Does it also come with an accuracy value?
No, this only comes with the outcome.
Okay.
Really the label. But maybe, I haven't checked that, if there's a possibility to add actually the probability of it.
Yeah.
I don't know. I'll have to find out. So now we've defined our flow, and we can get that data in. So we start just Power BI Desktop, for example. And we're going to get the data from the newly saved flow. Yep. Connect. Okay, we go to our space. It's this one. We saved it as HR39. And we got our data file. And it's empty because it's probably filling it out. Yeah, that's always the bad part. Now the table will be empty because it's still processing. But maybe. Okay, good. Please. Can't refresh. Be loaded. Okay. Just 1 minute to go. Let's see if we can make it work. Nah. Try again. And this is really a matter of time because it just takes a little bit of time. Nah, I'm sorry. I think we have to wait a little bit. I can show you at the end of the evening. Well, you get the idea. You get your data set in, and you have the prediction. And it's really the one-on-one based on your data flow. Unfortunately, it takes a little bit of time, and my time is up. But I will show you in a few minutes. I will just turn my screen, and then everyone can see that it's there. So that's it for now. Automated ML from A to Z with a little, well, Z shall be there, but I think you get the idea.
Any questions in the meantime, by the way? We've got time. I have to set up my laptop, so.
Any questions?
Oh.
The other cases with the same platform, I mean, the regression problem, multiple classifications, abnormality problem, recommendation system, all can be applied on
That's also a good option. Just to understand where your question was, because we have the matrix, let's say, at the right side. So
I think it was called the game graph. With the wires.
I will check it. Let's have a drink after and
Exactly, I can point
let's
it out.
find out. I will check it in the graphs. Any other questions? Or if not, then
Yes,
Ah.
the web service you showed, ML.net, that's a new one, it's a preview. What was going to happen with Machine Learning Studio?
this is not Azure. With the study, well, actually, Steph, maybe you can give a highlight on that with the Azure Machine Learning Studio.
You're talking about the visual interface or the entire studio?
The web service, the website.
So you're talking about deploying the model to a web service? Yeah, you can deploy to either ACI or Kubernetes inside the service, and it manages it. We also do crazy things like log the analytics to like app insights, and we do something called model collection, data collection to look at data.
Or are you talking about the studio where it's a drag and drop interface?
There is a web service which called Studio, and you see the FDA experiment. Is that going to be maintained, or is it going to be replaced with the thing that you showed?
I think he's referring to the Azure Machine Learning Studio as it was, so the Azure. So, but there is another visual interface also very similar where you can build your model visually and then export it, but also deploy it, for example, to Kubernetes or something else. So it's there also. So you had three options. You had the automated ML, you had the visual interface, and you got the notebooks. Now the second one, that would be your choice now, I think.
And then there's the old studio, but my advice would be use the new one.
Yeah. Okay. Thank you.
That's all I'm allowed to say. Cool. So what you just saw was automated machine learning using a more visual interface. There's also something called machine learning.net, which is machine learning in C# actually. And what I'm going to do tonight is show you, I've got a demo as well, a lot of demo actually. I'm going to show you how to use C# to do machine learning actually. And it's good to be honest up front. This framework is in heavy development. It's changing all the time. I've got the latest preview on my laptop. It works. That's a good thing, I think. A lot of stuff is still changing. The API is sort of weird in some places, but some stuff will feel familiar to you if you used Python before and scikit-learn or similar libraries. So I'm curious, who's doing C# development today? There's a few people. Less people than on a .NET meetup. That's good news. I'm using Python at the moment for and R. Very few actually. Okay, cool. So mostly Python audio. Then this will be sort of your introduction into C# a little bit. I'm not going to syntax in that detail, but you will get an idea of what's going on, and the people that are doing C# will feel quite at home actually. So imagine that you have a GitHub and you're building something called the .NET Framework and the .NET Core version of that. And you get about a few thousand issues on this repo. And you have to specify which team is actually going to work on the issues that people post to you. As Microsoft has run into this problem. There's other open source projects that have the same problem. Of issues, if you have roughly issues open that you need to take a look at and fix and maybe classify which teams should fix it, that's quite a lot, right? So I would say this is typically a job for a developer to fix, at least the classification part, I would say. I mean, debugging all the issues there, that's something else that the teams have to do. But getting a team, that's not, that you can't do it with this data. You can get an intern maybe, and ask him or her to go through all the issues that are posted and fix them basically. But that's impossible, let's be honest. So this is where machine learning shines in these kind of problems. You're a developer working on a project and you're doing your normal stuff and you run into these kind of issues. You have some problem that's unprogrammable. So if we're really naive, you could say, instead of issues to well, the old way, last year maybe. We did the data and it will classify my issues. Could work, right? A very naive strategy could be if there's something like system.io in the title, I could assign it to the IT. I could do that. But here comes the challenge. The problem might not be in system.io, but it might be related to that. System.io.ports, maybe. And that's a different team. There's people that are working on USB drive and Raspberry Pi. Then what? Find a new route, maybe? That could work, right? I could do that. As you can imagine, if you have a large repository, this is not going to work anymore. So comes in. Alternatively, we could say, well, let's get the old issues out of GitHub. You can do that. There's an API. Let's put them in a CSV file, including the area for the issue, the team that has to work on the issue. And based on this historical data, I can say, figure it out. Make me a function that classifies my GitHub issues into all the areas that I know. This is a machine learning model you can run and then feed me data that anyone can post on GitHub, and I can get the data from my GitHub API into this new model, and out comes the area that needs to be assigned. This is exactly what we're going to do during this talk. Provide me with a pretty good data set for that. They cleaned everything up and made sure that it's readable. And we're going to build a machine learning model using ML.NET. So ML.NET is a C#-based, net-based machine. And you can build custom machine learning models. If you got something that can be solved using a standard model, you can use things like text recognition on Azure. There's a standard cognitive service for that. But it wouldn't work in this case because I have got custom data, essentially, and custom categories. So that's why I one for and we're going to use the command line utility that's included with the framework to build a machine learning model in an automated fashion. So what's good to know, ML is not something very, very new. Well, it's new on GitHub, but it's not new at Microsoft. What they told me is that ML is invested by a couple of teams for their machine learning needs. Not everything, but there are a few teams that are using it internally. So it's in that sense proven. Is it perfect? No, it's not. If you ask me, API is somewhat weird sometimes. And I will show you in a minute what I mean by that. Still, it's pretty fast. It works. So if you're in a pinch, like managing, this is a great solution. Microsoft is investing heavily in cross-platform source. So ML.NET is fully open source. It runs on Linux, Mac, Windows. I haven't tried it on my Raspberry Pi, but it probably runs. I'm actually pretty sure that it does, so that's pretty cool, I think. The use case that I think ML.NET will really shine in the future is using TensorFlow models. So if you have a data scientist at your company that has built a model in TensorFlow on his machine or in the build pipeline, and you can load it up in ML.NET and make predictions with that. So Python is really, really good at building readable programs. It's not so good at runtime. It's not very fast. In contrast, ASP.NET Core does 3 million requests a second. So that's a lot faster. So typically what you would do is ask your data scientist build a model in the language that he or she prefers, and you run it in C# if you're a normal developer. So this is really cool, I think, that you can do that. A bunch of things you can build using ML. It basically does everything. Mostly the classic machine learning models, but like I said, it also does deep learning, at least it does prediction. And in the latest preview, it also includes support for actually training image classifiers, specifically using deep learning. To bother ourselves with GitHub, we're going to build a labeling tool for our issues. So before we dive into the code, let me explain a little bit about what ML.NET actually looks like under the covers. We're not going to look at the internal code. I'm just going to explain a few concepts. So people that have done machine learning or data processing, especially in Python, will feel quite at home using this API. It's a pipeline. Data goes in, it's transformed, either through pre-processing or cleaning, and then it goes through a machine learning model and outcomes of prediction. Basically, the machine learning model will transform your input data into a prediction. So, for example, if I have a GitHub issue, I need to transform this issue into a set of numbers. Machine learning is all about numbers. Machine learning is text. So I have many times this word happens in the end. I can say to ML, I want to factorize text into numbers. That's one thing. Outcomes is a set of numbers from a machine learning model, and I then say, well, I've got another field that I want to factorize. So first I factorize the title into numbers, and then I factorize the description into numbers. And then I can say, well, these two combined are the inputs for. So the final step in my machine learning pipeline is an estimator. An estimator could be a regression model, a classification model, binary or multi-class. Recommendations, you can do an action, you can do a number of other things. So this is the basic model. I'm changing a training set. So why is this important? Well, once you train, this estimate on the right becomes fixed. I no longer need to change the parameters in the model. I've trained those, I know the correct values, and that's it. But first two bits, like an issue, I still need to factorize the title and the description for this thing. So basically what you can do in ML.NET is say, I'll save this whole pipeline to disk in a zip file, and the next time I need to make a prediction, I can load up this zip file, and back comes my pipeline pre-configured in the correct way using the trained model. So that way, on one computer I can create a model, and I can be sure that on the other computer, someone that uses my zip file will have the exact right setup to make a prediction. Otherwise, if he would retrain these two parts, right? So this saving of pipelines is a really cool ML.NET. This feels slightly familiar to Python, right? Anybody notice that scikit-learn does the exact same thing? That's where I think they got the idea. Okay, so enough talking, let's do some programming. Where's my mouse? As you can tell, my computer is especially fast tonight. Is this big enough for everyone? I can bump it up if needed, but so what you see right here is my terminal. It says it's a PowerShell terminal. I've got a directory in which I have a couple of files ready. So it has a data folder, and if I go into this data folder, I've got the original file, core-fx issues.tsv, original training set that Microsoft published. But I split it into a 90% training set and a 10% test set so that I can validate my own work. I'm not going to bother you with that. Actually, to be honest, I haven't found any API in ML.NET to actually split a CSV file in a training set and a test set. Also, I haven't found any tools in there to pre-process my data and clean up all the mess that people normally produce in their data sets. So that's something that you have to ask your data engineer for, or your data scientist. Once you have the data set, you can start in ML.NET. So what you can do then is go into this command. So for people that aren't familiar with .NET Core, it used to be go into Visual Studio, this lovely purple icon. That's my second OS. It takes up quite a bit of memory. And I would make a new .NET project, and it would run on Windows longer. You can do this on Mac, you can do this on Linux. That works as well. And .NET Core comes with a command line library called .NET. Cool, same thing for Python. And I can say, well, .NET install a command line utility that uses .NET. And in this case, I'm going to install the ML tool. And the MLNet tool, I have it on my machine, so I'm not going to run the command actually. It offers a rather limited set of features. So once it's booted up, it has only one command actually, auto train. It's pretty limited, but let's use it to build a model. So what I can do, I've got some demo notes to help myself. So what I can do is I can say, well, dear ML.NET, I want to train a model. I want to train a multi-class classification model. I can do regression, I can do the other one as well. Then I will feed it a set. In this case, I'm going for the time being, I'm going for the full training set of Microsoft offers. Then what I will say is -n, this I'm going to predict. I'm going to predict the area of the issue, using all the other columns that I have in my data set. Then I'll say, well, what's going to happen when I run this command? It's going to try different models and pick the best one for me, including pre-processing, including everything that you need. This takes up time. So I could give it 5 minutes, I could give it an hour, depending on the size of your data set. You might go and say, well, let's spin it up for 2 minutes and see what happens. I might shorten that based on the fact that I don't have a Finally, I will say output the generated project into the SRC folder and give it a name, GitHub issue classifier. So let's see, let's modify my time for searching a little bit and run it. Oh, I'm one folder too deep. Let me run it again. So what will happen now is it starts to search for a model, and it will print out over here. That's about it, what you get. You will get a log file that explains a lot more about what's happening. Well, once this is done, I get a C# project that has 2 parts, actually. It has a model and a console application that demonstrates how to use the model, which is pretty cool, I think. What we're going to do is we're going to build an ASP.NET Core API on top of my model. Imagine you're building a microservice architecture, or you're building some application you want to use the model. So when we look at the output, in the SRC folder, I can open up Visual Studio Code, which is awfully slow. Give it a second.
Expired before creating the model.
Oh, yes, indeed. We need to give it more time. Aww.
Give it a minute, come on.
Yeah, Oh yeah, and I'm still in the wrong folder, but let's give it a minute. And the good thing is I came prepared. I have a website, no, I don't. So, to be honest, this takes a little bit of time. My data set is too big for a model in 30 seconds, but you get the idea what's happening over here. In the meantime, I can show you actually, I can show you the log file, which is, so this is what happens underneath. It will fire up the trainer, and if I'm not mistaken, it should be. So this will contain at the end all the logging that is output by the tool. Let's see, it's almost finished. Come on. Yeah. SRC. Ah, it expired again. Bummer. Okay. I've got a backup plan. So normally you get out a model. I did come with a backup plan, of course. You can do this by hand, you can do this automated, the result is the same. What you will get is a project that looks very similar to this. So it will output a model project and it will output a console application. In my case, I renamed those and I changed a few things around. So this is a one-time process. You can do this once and it won't update your model. You have to manually train it afterwards. That's the one thing that is annoying about this solution. So when we look at the model, ignore this class, you will get an input class, GitHub issue in this case, and it's a C# class like you would expect from any normal C# application. It's a public class, GitHub issue in my case, and there's something special about this. So it has the properties that are in the original data file. An ID property, don't know why that, an area, a title, and a description. Actually, these last two are the ones that you're interested in. These are the ones I'm going to provide to the model. These are marked with attributes that say, well, load the ID property from the first column in my file and load the area from the second column, etc., etc. This is how ML.NET will understand how to load your data files from disk. The same goes for the output. It has a column name, predicted label. And this actually matches my pipeline that I created. So what will happen is, at the end of the pipeline, I will have one column that contains a prediction, and I have to map this to a C# property. Otherwise, it doesn't know what to do with the data. When you use AutoML to generate this project, this is all done for you. You don't have to understand anything of that. But it's good to know that it's there, and you can use it later to customize things. So now, what do I do when I want to use this? So what's good to know for people that are a little bit more familiar with C# programming and .NET programming in general, this pipeline that I created, for only one thread. Only one person is allowed to call my model at a time. If I've got two people calling the model at the same time, which is possible if you have a website, because you have multiple visitors, then stuff will break. That's bad. Luckily, Microsoft provided a solution for that in the shape of a prediction engine pool. So what you would do is you would say to ML.NET, create me a prediction engine for my model, load my model from disk, using the file, and call that directly. In ASP.NET Core, it's slightly different. The API is pretty much the same, but this is the correct way to do it in a normal application. What I'm saying, ASP.NET Core, for those that are not familiar with that, basically has a HTTP pipeline in there that you can configure. You can say, well, I want API controllers, I want pages, I want static files, I want HTTPS. All that stuff you can put into a pipeline. This pipeline is supported by a number of services, dependencies. So what you typically do if you build an ASP.NET Core application is you build a startup file for the application and specify these dependencies using configure services and the pipeline using configure. These are the two methods that you typically build. And this is automatically executed by the runtime, by the ASP.NET Core runtime to build your web application. So what I have to do to build my machine learning service is first configure some dependencies in my configure services method. Here I'm saying, well, I want to use web pages and I want to use routing. I want to translate a URL to a page, basically. Then I will look up the model file from my application directory and say, well, add a prediction engine pool for my GitHub issue to GitHub issue prediction pipeline from this file. And give it a name. What you can do is load the same model multiple times using different names. That works. I haven't used that ever, but yeah, it's there. So once I have these dependencies, I have to say, well, I have a HTTP pipeline that uses routing to translate URLs to pages. And when I have the endpoint determined for a URL, I want to use a dynamic page to display content. So basically what happens is if I start my application using .NET Run, website, .NET Run, let me tell you, this was one of the fastest laptops you could get. It has 64 gigabytes of RAM and it's very slow. Don't know why. And it's not charging either, so that might be the problem. Yeah, it's not charging, so interesting stuff. But it's working. HTTP localhost 5000. And this is what I get. So this is my page. I can enter a title. I can say this is my test issue. Some description, and the cool thing is, it says it's a network issue. Oh, there you go. So that works. Why does it work? So I haven't shown you the last part that you need. So I've got this Razor page, which is a dynamic page that you can build in ASP.NET Core. It can contain HTML code for layout and formatting. And it can contain C# code, actually, to render dynamic pieces. So this is actually a two-part thing. It's the HTML that you see here, which is quite a lot, actually, for something so small. And there's a C# file that basically backs this page with behavior. And what I can say is, well, when you submit a form to this page, execute some code. So what I get from the client is an input form, which I've purposely bound to a input property that has the title of my issue that I want to classify and the description of the issue that I want to classify. What happens, I translate this into an issue instance and say, well, dear prediction engine pool that I created earlier as a dependency for the page, do a prediction using my GitHub classifier model and use the issue that I just created from the input that I got from the user as an example for that. What you get back is a prediction, a GitHub issue prediction instance. And that happens to have a property called area. And that's what I display in my form. So it's not a whole lot of code to get this working, actually. So what do you think? Is this something that you'd like to try sometime? I can see some nodding. Cool. Quite happy. Did you know about ML.NET? Okay. You don't? No? Sort of, heard of, but never tried? Yeah. Cool. I personally feel that this is quite a good tool for things like what I just showing you, you're sort of hacking projects on the side as a C# developer. This is excellent. You just use automated machine learning. Don't bother with all the numbers and balanced data sets and validation, etc., etc. It's all important for customer projects, but I would say if you're trying to fix a problem in your own development process, then it's somewhat important that it works correctly, but if it got it right 95% of the time, I'm quite happy with that. So that's how I think of using ML.NET at the moment. I wouldn't use it in production. The API, like I said, from what you've seen, it's very little, but there's a lot more stuff in there that you can use, and it's all pretty funky. I can show you one example. So I actually built a manual trainer. This is sort of the insight into. So here you see the pipeline, which gets nastier every minute. So I start out with an ML context, and I load some data from disk. So I can call the data property on that. And I can say load text from file, which is in a GitHub issue format that I specified earlier. And that gives me data in a streaming format, actually. So it's pretty efficient. If you have a 1 terabyte text file, it won't blow up your computer. It will be just slow. That's it. What I can then do is say, well, I've got these transformations, and I can convert a value to a key. I can say featureized text. I can say concatenate, and a number of other transformations that I can add to the pipeline. This builds the pipeline. Like I said, this is a little bit funky because what I expected actually, this data over here, I would be able to add on that or extend or something instead of doing this. This assumes you have one pipeline. This, it might be right, but I don't know. Just so you know, be aware that this happens. That is something you have to keep in mind. So once you have this pipeline, you can add an estimate of it. And this is the trainer, and finally some output transformation. And this is basically it. This is what happens in ML.NET, even in automated machine learning. They build pipelines, they train the model, and then estimate how well is it doing. Maybe there's a better model, and try again and again. Does it make sense to people? Yes?
Is it also possible to do the same in Azure DevOps? Or do you have experience with Azure DevOps?
It depends on what you're thinking of in that case. So
Doing the same solution like this kind of pipeline in Azure DevOps instead of in Visual Studio Code.
yeah, you can do that. So, well, you have to build your C# program in Visual Studio Code or in Visual Studio and compile it, and then you can run it on your build server if you want to, and save the model file as an artifact that comes out of that. You can do that. But it's not like there's a dedicated task in Azure DevOps to do this kind of work. Especially, there is for Python, but there's not for C#. So that's the difference here. I think the whole story around Python is a lot farther ahead than the stuff that's happening in C#. And there's still a long way to go for C# actually. Yeah. Yes?
Do you get any model feedback, like the performance or metrics?
Yeah, actually you can. You can get that out of there. So I haven't shown you, but in my trainer program, I actually call this code cross-validate. Let me move away my mouse. I can use cross-validation. I can use normal validation methods. So if I have a test data set, I can run that through the model and see how well it's doing. And in my case, I print this out on my console, and it's rightfully a confusion matrix. When you see the output, it's no good at all. But it's just for debugging purposes and give you a sense of what's possible there. So yeah, you can do that. Yeah. Any other questions? Yes?
Is it possible, maybe in the future, from the portal we saw in the previous, use that
So is it possible to export models and use it directly in ML.NET? It depends. The zip files you can't export from Python to this format. It's not compatible. But there's a catch. So if you export what you've trained in Python to Onyx, you can definitely use it here. For project, you can save the TensorFlow file and use it in ML.NET. It's a API. That's it. Yeah. So that's why I think ML.NET is a good use case for people that want to go into production. C# is just in Python, and much easier for the C# developer. Yeah. Any other questions? Cool. No? Nice. So if you're interested and you want to learn and you like to learn more, last AI night in September, I made a tutorial. I only was able to do it with 20 people, 26. It's still up on GitHub. You can get the and it explains in great detail how to use ML.NET to build a model yourself, step by step. Actually, this model. So you can follow that, and there's videos included. So if you're confused what to do next, I've got videos up there as well. And with that, I'd like to thank you for your time.
Yeah, and I think we come to Jurkie at
Should we take a break? Everyone take like a 5-minute break? That would work, right? It's been an hour.
So let's take 5 minutes break. Please be back on time.
I have not seen it. It's cool.
Ja, jammer dat die demo nou zo traag is. En mijn laptop is gewoon traag, want hij kan het echt wel in 30 seconden.
Kijk er maar in af. Als ik nou inderdaad maar 60 seconden zet, zet hij dan maar op je seconden.
to make sure that I'm recorded. Okay. So today I thought we would just talk about like whatever you wanted to talk about, but I was going to give you some options, okay? I could talk about what the latest on Azure AI, but Marion did such a good job that I would ruin it, right? That was beautiful. Like I was like, wow, I should do that demo because that's amazing. She showed AutoML, she showed the new workspace, she showed the new data sets concepts. And it's and all of it, like it's a that was a I was messaging Cassie, I'm like, this is really good. My presentation's gonna suck. I think that's what I said, right, in the Slack? Okay. So these are our options, and we can do any of them. But I've found that like a lot of the demos that we talk about, like stuff happens and you're like, hey, that was AI, and then you have no idea what's going on. So I can talk about like how it works, like literally exactly how it works, and do that. Or I could show you what's in Azure Machine Learning Service. I can do like a tour around the workspace, what's in there and how it works, but I won't tell you what it's doing because that's the machine learning bits. I could talk about ethics and AI. We have for that. Or I can talk about whatever you want. So what I'm going to do is I'm going to give you all a minute to think. And by the way, as we go, because sometimes people don't like asking questions because there's other people, you know, and you don't want to sound dumb. Because there's no such thing as a dumb question. There's only dumb people. So what you want to do is you want to go to aka.ms. And if you type something in that box, it will go right to my phone. And it will ding me. And I won't even know who it is. There's no names. So no weird things, okay? Because if it's super weird, I'll just stop and we'll read it all. And so what happens is during like any good breaks, I'll just go in there and be like, all right, what did people say? So who's the first one that's going to try it? So to make sure that it works. Because I wrote the code for that crap and it may not work. So you put something in and you should hear my phone ding. And then I want to hear a lot of dings. Or just raise your hand, okay? So I'm going to give you like a be like, do you just do these things till time runs out? There you go. See, it works. Good job. Do all these things till time runs out? Is there one that you want me to pay special attention to? Would you like me to do something else? It's all for you. The only reason I'm here is for whatever you want. Okay? And if something doesn't make sense, that's my fault because I'm a bad teacher. And then I can rephrase. Okay? So I'll give you 60 seconds to think about where you would like me to start, and you can put it in the box. By the way, I turn that off after session, so don't be like middle of the night like, yeah, I know it's 2 o'clock, but for Seth, it's like 1 a.m. where he lives. Don't do that crap. So a minute, and I'll warn you that when I ask questions, like I would love to hear answers from you all, and I used to teach like high school in the US, and so awkward silence is basically only awkward for you. Doesn't bother me one bit. All right, so let's see what people are saying to me here. I'm going to put this down. 10. So it works. I didn't write it. It was Microsoft Flow. Beer. All right. What's new? Okay. All the topics. And then I have a talk, ethics and GDPR. How does it work? What does Azure do with cybersecurity and ethics? How does it work? Do you have standard data sets, for example, weather? So the answer to the standard data sets is we do. Where is it? What's it called?
Visual interface or standard data? Oh, is that what you're talking about, or MS Open Data?
We have, well, see, we have all things. So she.
Actually, there's two different, I can't remember the name of the second link, but I can get it to you. And then the other one's MS Open Data. And then there's also, if you're using Old Studio, you use that. There's a bunch of data sets you can use to start playing around in there as well.
Yeah. So, by the way, this is my colleague Cassie. She's with me, and I'm with her, and we're the same team. So, she knows basically everything that I know, but probably says things better sometimes. So there is that. Okay, so we have ethics. How does it work? Standard ethics and AI, foundational. Azure Machine Learning, what's new? All agenda. How does Azure ML perform with really, really big data sets? Well, it turns out that it doesn't matter how big it is because you can load terabytes of stuff in the blob storage and mount it onto the experiments as if it was a hard drive. and it will just read off it. So I think well. Can you share how you did this? Make this aka.ms? Yeah, it was Microsoft. And Microsoft Flow take. That's it. You thought it was better than that. What's new? So, okay, so I'm getting a good smattering of like this and this, okay? And then for this one, I can show you something. Mernouche, who works on it, we did an Azure, there's a show that I do called the AI Show, where we do one that's not out yet, and I took out all the best bits where I'm not talking, and I'm going to show you that. It's 8 minutes long if we have time, because it's super cool. This is crazy cool. So I'll just go in order. Looks like everyone decided. Where did I do? Here's my clicker. So if you're like, I already know this, just be like this, and I'll just move on as fast as I can. But for some people, sometimes I feel like they show up to machine learning groups, and it's like, I feel like everyone has this secret knowledge. In reality, no one has it at all. Everyone's like, do you know? Do you? And so, the secret knowledge out of this. It was better the other day. Okay. A big flow to build. Basically, that people do is church. The Minimax and those kinds of tree search algorithms that prune the space. So the search space is infinite. Look at a problem and you look at the complexity of it. If the search space is finite, you might not need machine learning. So you think about that. Example I gave earlier today. And finally, you have deep learning. Machine learning, you have something called decision trees, which makes like an. Now, that's machine learning. But works in machine learning and deep learning really depends on your marketing guy. Have to be before they're deep learning. I guess it's a question for how deep does it have to be deep learning? We don't know. Depends on your marketing guy. Earlier, so if you heard it, I'm sorry, but imagine you work at a bank. Anyone work at a bank? There's like 2 people every time. There they are. There they are. Sorry, first of all. Programmers that work our banks are like janitors of computer science. Thank you. You work at a bank, and one day Steve, the marketing guy, comes and says, I have a really good idea. And whenever the marketing guy, Steve, has a good idea for a programmer, what do we say to Steve? Yes. Sure, Steve. I don't know when people put their checks to our type. I know this is like an old story because now it all sees the checks for you. Do you even use checks in this country anymore? Are we like cavemen in the United States? Basically, this story is from 1952. This is terrible. Slide has. Imagine you work for still uses paper checks because it's 1992, right? And what Steve said is like, look, if you could write an algorithm to tell me whether the check is upside down, that would be legit. Could you do that? Well, let's pretend your bank is really crappy. Well, all banks are really crappy. And write like this as a programmer? Right? The image. I can do it, but it's going to take 6 hours. It's really going to take one, but there's a lot of YouTube to watch. Right? There's a lot of YouTube out there that, and who's going to watch all of it? Have to. So you write live, right? And then things that we programmers do when we're trying to get stuff done. You know what I'm saying. All of you know. Maybe shut the door. There might be bosses here, right? Are people looking? And then Steve comes back 6 hours. This is glorious. So Steve was the CEO of the company. Mary owns the bank, and she's like, "It. Can we just do one thing?" And then Steve comes and is like, "Hey, this one." Anytime the marketing guy Steve says, "Can we do this one thing?" it's a terrifying thing because we have no idea what they're going to say. They're going to make it easy. It's just one button. Have you ever had them say that to you? Just one button. Just launches SpaceX into the moon. And, one button. Wouldn't be a bank CEO. To be a bank CEO, is that how it's here too? Picture of her horse on her check. Check picture, right? Now you're a programmer. Can you do this? Yeah. Of her stupid horse. Stupid because obviously she's the CEO and her horses. So they give you the picture, and what do you do with it? Well, you're a programmer, right? You're going to go through and be like, well, it's darker here and darker there. Write a lot of if statements and for loops, and that's going to be code that you made somewhere. You did that. Take an extra because you had to write that crap, right? And you did it, but you did it. Right? It's going to take 4 hours. No, there's a lot of YouTube to watch. Right? So then Steve comes in and have a really awesome idea. Right? Notice that the complexity went from not too bad to it's kind of bad, but I can still do it. Steve comes down and says, you know, for every person, for every picture, for every. Do you see how your programmer brain just exploded? Did you feel that? You felt it, right? That gap is huge. That gap is where machine learning works the best. Okay, think about it. You've all written code where you've had to add an if statement, every other week, and you've had to change the number from 0.5 to 0.7, and it somehow kind of worked. When you smell or machine learning, okay? That's when you use it. And that's the best way that I understand how to use it. Okay? That's how I do it. When you program it, complex. Okay? So, think. Okay. Machine learning. It just makes functions. These are called models. This is a function. I'm going to show them. I'm going to open them up. And there's not going to be butterflies out or saving some things. Like everyone says, it's basically a way to serialize a function in a different way. It's actually a lazy way. And has to watch. What did build a model? And everyone was like, okay, you saw all these models being built. They were great. By the way, that tool he ran, you know that figure out which model to use in ML.NET, it's actually automated machine learning. It's the same algorithm. If you use Azure Learning Studio, the old one, called TLC. ML.net is. I don't know if you knew that, but I want to just fill that in for you. TLC, sometimes it shows. And now all of a sudden you're looking at this, you're like, well, this doesn't look so difficult. But then some questions you have, right? For example, what is the magic and how does it work? Algorithms to giving the computer data and then it figures out the algorithm itself. That's what it does. That's machine learning. You all knew this. And if you did know this, this helps you when the gap is useful for machine learning. I think I read in CM like 40% of companies have AI in their title don't even use it. So they just, all you need to say is like AI and then like blockchain and you're totally get all sorts of VC. Always have to start with a question, just like someone doesn't come up to you and say, hey, just write a program to do it. But everyone every day comes, thanks, Steve. It's really that learning can answer well. That are good, that you can do if it's more cheap. The question is how, like you want to predict. You want to know if it's weird. And learning, supervised. Right? And this is like weird. And then when you put it like that, then it's easy. But the process, right? Because this you have no data, you have no machine learning. Okay, you need to have lemons and you're squeezing them. No lemons and you want to make lemonade. That's a problem. Like if you have rock, try to make lemonade. It tastes very good. I mean, I guess it depends on if there were rocks from here. Because this seems like a really clean country, you know? We may need to take this offline. Okay, all right. Data, because for those of you that work at bank, there's a lot of garbage in your data, right? That's why they're the data janitors of the computer science area. Yep. Then after that, the majority of the time is here. Garbage. More. You got to separate data into a trace. Here you trace, test it with the dev set, and you loop here, and then when you're you have a problem. Another, you're noticing that it's getting really good, and then all of a sudden it sucks. You have a learning problem. Right? There's a bunch of a horse. How good these things are doing is I think is important. If it's not sure, what should it do? Go see a doctor. It's not sure, right? So there's other measures, like when it comes to truth, how good are we at predicting it? That's called recall. The next one is when we guess truth, how accurate are we? That's precision. You see that? Those are different things. And so, and by the way, if you go to Wikipedia and type in confusion matrix, obviously Chrome will crash for a second, and then you bring it back up. There's terms for all of these, right? But these are the ones that we focus on in machine learning. There's other ones too. Like for example, like this one, I don't remember what it's called. Let's call it Thor, just because he's a good Avenger. So I'll start with this one because it's easy. Numbers, I know it's stupid, but I want you to actually see, I want you to see inside of a neural network. Okay, I'm going to show you inside it. Have you all looked inside of neural networks before? Once you see inside, your life will change. That wasn't that funny. What's wrong with you?
I'm just really tired.
Oh,
so
got
it's
it.
funnier.
Okay, so I want you to squint into the matrix and tell me what number is that. Rhymes with snive. Starts with a F. Any guesses?
5.
Good job. Good job. Yeah, so this is just a 28 by 28 matrix that has numbers in it to represent the intensity of the pixel value. Right? So this is the pixel 5. So if you go back, that's that one up here. You see that? 5. Don't look too hard. You don't want to get trapped in the matrix. So that's what you have to give machine learning. Only numbers. You cannot give these things like text. Like they have no feelings. These things are dumb. And I was in a panel with marketing guy Steve and some other marketing guy from other companies, which I will not name. And we were at like an educational conference, and they were all going on about how AI starts to think. And I was like, sorry, Steve, but humans are weird. We can put a smiley face on a rock, and you would think, oh, it's happy. It's a rock. These things don't think. They have no feelings. They have no. You know it's true, right? You have rocks at home with smiley faces on them, don't you? I knew it. We really want is this, right? That's what we want. We want an int-get digit from the picture. That's what you want. In machine learning terms, we are basically going to build a function that takes a thing and outputs a thing. Right? That's what we do. Now the question is, well, what does this look like, right? And what does this look like? This is easy because it's that matrix thing. This is harder because we don't know. Now, here's the thing. I don't know why that slide is there. Let me show you a thing to help you out. Oh, this is a thing. I did want to show you this. So we know what the x is, right? It's basically this thing right here. That's x. That's the thing coming in, and it's a bunch of numbers, and it's the same size every time. Now we want to know what the h looks like, and I'll give you an example. Okay, so I'm going to do a really dumb example. Do not use machine learning for this. We're just going to do it as a thought exercise. Okay. So here is a 9-square problem. Really stupid problem. You have 9 pixels, and you want to write a machine learning algorithm to predict whether it's darker at the top or darker at the bottom. Okay? It's dumb. Don't use machine learning, but I want to motivate a thing to do another thing for the other thing so you know what's going on. Okay? So over here, hold on, let's see if I can use this. So this represents the 9 pixel intensities of the first one over here. Is it darker at the top or darker at the bottom? Yeah, darker at the top. How do you know? Did you look at the numbers? Look at the numbers. These are the top 3 pixels, middle pixels, last 3 pixels. So if you were to write it up, and you could go ahead and use your programmer lizard brain, how would you write this algorithm so that if you were given these 9 pixel values, you would guess whether it's darker at the top or darker? What would you do? Sum. Oh, it's just sum of what?
Sum of the numbers.
Of which ones?
All from the top.
So top 3 sum,
Yep.
bottom 3 sum,
Yep.
and compare.
Yep.
Nice. So this country is a lot smarter than many of the countries I go to because they're always like, you should take the average of both. And all of you are like, ha! That's why in America they call it math, not maths. Like everywhere, is it maths here? Like you have plural maths. In America we have, oh, you only have 1 too? Who's from the UK? They have like 2 or something. It's maths, right? With its, I don't know what extra they have. But anyway, basically taking the average of both is the same as adding them, and you can take the divide by 3 out of both sides and it still works, right? So add the top 3, add the bottom 3. Okay, now I'm going to force you to do something that's going to be a little bit uncomfortable, but does not violate the code of conduct. Sorry, I'm tired. You write that one down.
Yeah.
I'm going to force you to put it into this. Now imagine you have the 9 pixels coming in here, and I'm going to ask you to pick some magic W's such that when you multiply each of these numbers together and you add them, you still get the right answer. What numbers would those be?
Together should be 1.
Okay, so the first 3, if they're 1s here, you're multiplying these by 1 and you're adding them together, right? Which is what we want. Good, absolutely. But what should the other W's be?
-1.
Where?
-1, right?
Where? Here?
No,
The last one. Because when you do minus ones here, you're basically adding these together and making them negative. What do we do with the middle ones?
Zeros.
Boom! So now what you've done, see, this is why this is really smart country, right? You basically are adding these, take the 1 out in front, and you're subtracting them, basically, the sum of them. And if it's more strong over here, the answer is going to be negative, you guess. If the answer is positive, you guess. Any questions? That was a trick question. There has to be a question. Nobody asked me what that B was. Shame on you, all of you.
yeah, it's good.
No, this is another number you just add in. You pick a B. What B would you pick to make this work?
0.
0. But listen, what if you wanted to make it such that the top is not darker than the bottom, but if it's close enough, we still want to guess top? Then you add a positive number and it biases it towards the top, right? If you want to guess bottom more often, right, if it's within a certain couple of things, you add a negative number and it biases it towards the bottom. In machine learning, this is called the bias. It's true. Yeah. So basically, you people just made a machine learning model. Let me show you. These numbers go in, these numbers come out. At the bottom, you see 236, you guess top. Same thing with negative on the bottom, right? You see negative 234, you guess bottom. That thing, that W and that B is a machine learning model. And that thing you made is a prediction. That's it. All of you are saying this is not machine, this can't be machine learning. This is basically logistic regression. Who's like the real data scientist out there? Not me, but like a real one. That's basically logistic regression, more or less. It's just that you add a sigmoid on the outside and the cost function's different.
Somewhere between 0 and 1.
+1 and -1 in this case. This is basically logistic regression, and you just made it up in your head. You're probably thinking, but I thought deep learning was new. No, this is the foundation of deep learning, and this thing was invented in 1954 by Frank Rosenblatt. Turns out that AI has gone through several winters from the beginning of time. In fact, when I went to grad school, we were in our deep AI, we were in our neural network winter, our 3rd one, and I thought they were stupid because mathematically they weren't as nice. Okay, so you're probably thinking, great, I don't believe this. What if I wanted to guess top, middle, and bottom, Seth? How would you do that? Well, you just make 3 of them, right? And then you put them together like this, right? There's this number. And then you take this thing like we did before. Remember that little tree thing where we multiplied by the numbers and then added them together? So you take this thing, you turn on its side, and you go num, 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 and then out come numbers. This is basically the Cookie Monster operator. And out come these numbers. And which one is the right answer? Max index. Do you see that?
Middle one.
Is this the highest number? This is why we only have one math in this country, I think. Because in America, this one's bigger. Right, this thing that you figured out, this W, and I omitted a B, by the way, you would have a B with 3 numbers in it too. The bias, I just left it out. This thing is the basic unit of all neural networks. Did you know that? This is now a new machine learning thing. The thing comes in and guesses top, middle, bottom. The same thing. With that number thing, you do the same thing. Like with this one, these are what the features look like. This is what the output looks like. And now it's, instead of this, it's something a little bit bigger like this. Doing this model and optimizing it in the standard array will get you almost 92% accuracy. And this is stupid. How do we get all the W's and B's though, right? Are you gonna go and like guess them, you know? We're gonna guess them all uniformly at random until the thing works, right? How do you guess all these numbers? Well, I'm gonna show you some stuff, and I gotta look at my clock because I don't wanna run out of time. Oh, good, I'm doing great. What time is this done? 10 o'clock? How do you guess these numbers, right? There's a lot of them. Did you say 11? No.
Definitely not.
Oh. I know, that's too soon, right? Well, we want to minimize mistakes. And so what we're going to do is we're going to use some maths, like the UK kind, like the extra bits of math. And I'm going to make a function that looks scary, but when I show it to you, you'll be scared at first, but just like when you jump in the cold pool, you're like, and then you swim around and it's okay. You're like, oh, this is good. I feel this now. This is great. So this is our function that guesses stuff, right? This is our function. This is the thing that's the right answer. Because remember, we have to give it the answers and the data. Remember that? The input and the answer. So here is the input. Here is the answer. When we get the right answer, if we guess the number 0 and the right answer is 0, what does this equal?
0.
If we get anything other than the right answer, what does this equal? Not 0. And then we square it. To make it even worse. we want to really penalize this when you get the wrong answer. This is called the sucky function. How sucky is our machine learning model function? The data scientists call it the cost function, but it's not as cool. Or the loss function, too. For those of you that are data scientists, mean squared error. Right, this measures how bad we are at it. And what we want to do is we want to find the parameters W and B such that this is as low as possible. How do we do that? Well, there's a square over there, so it kind of looks like x squared, so I will draw x squared because that's what we got to do. You see the square over there? So this is basically the same as this, right? Squint, you'll see it. Right, x squared. How do you know where the minimum of that function is? Where is the lowest value of y? 0. How do you know? Because you looked at it. I got it. But let's pretend you're blind and you're just sitting up there like 2D Super Mario. How do you know if you're at the bottom of that thing? Blind Super Mario. How do you know?
Let's start walking.
Start walking. And if you're walking and you're going down, you're going in the right direction, right? If you're walking and you're going up, it's a problem. But what if you want to make a decision at that point in time? Well, Super Mario obviously is going to put his foot forward and be like, ooh, down. And his foot back and be like, ooh, up. And he's going to measure this tiny triangle. Let's just call it dy and dx because we want to. And then what we're going to do is we're going to divide them, right? And then we're going to make these little tiny slices go infinitely to 0 because we can do that. And then that will tell you what the slope is at that point, right? Congratulations, this is calculus. Good job, that's all it was. I don't know why they made it harder than this. The derivative of this function tells you the slope at every point. The derivative of x squared, can anyone guess? Don't look over there, I can't reach. Do you want to know how I remember this? It's so stupid. So it's like when you take the derivative of a polynomial, the person upstairs moves to the downstairs, and they're so sad that they lose a person, they subtract 1. What's the derivative of x cubed?
2 times x.
3x squared. Because the 3 moved down, and they were so sad they lost the person at the top. It's crazy, right? It's stupid. But I remember that forever the rest of my life. And then the other ones you just have to memorize, not as fun. So basically, everywhere at this point, you know the slope of this function, right? So if you're at x equals 3, right, the value of the function is x squared 9, right? What's the value of the derivative? 6, positive 6, right? At 3, so 2 times 3 is 6. So if we know that the slope is 6, which way do we want to go? Negative or positive? Well, if we're right here, do we want to walk in the negative direction to get to the bottom or positive? Kind of laying them out there for you, okay? It's a lot. I know it's. You want to go left. So what we do is we subtract the value of the derivative. So what is 3 minus 6? Minus 3. Okay, good. Okay, we went in the right direction, but we had a problem. What's the derivative of minus 3? Well, 2 times a negative 3 is a negative 6, and we're at negative 3, and we subtract a negative 6. It's basically 6 minus 3 because there's no such thing as subtraction, only addition of negative numbers. That saved my 4th grade, by the way. There was no such thing as subtraction, only addition of negative numbers. So I put a plus on every single minus and put a little negative next to the other number. That's how I passed 4th grade the second time. So basically, now that you're here, right? Minus 3 minus a minus 6, that's like 6 minus 3. It puts you back over here at 3 and you're bouncing around forever. That's not good. So what you do is you subtract off a fraction of the derivative. So if we take half of the derivative, if I'm at 3, and then I say I'm going to subtract half of 2 times 3, right? That means that when I'm here, the derivative is 6. If I take half of 6, it's 3. If I subtract 3 from 3, it puts me in the exact right spot, right? That fraction is called the learning rate, and that is called stochastic gradient descent. And that's the workhorse of all deep learning algorithms. That's stupid, huh? If you've heard of an atom optimizer or an RMS prof, it's a variant of stochastic gradient descent. Stochastic means that you give it batches of data, your initial W's, and you subtract off a fraction of the gradient of the cost function. And you do this in a for loop for as long as it takes. And that's how that works. By the way, if you're interested, I know there is an arithmetic error with my calculus, and I apologize. For those of you that found it, I'm sorry. The 2 did not graduate like he was supposed to. So there should be a 2, right? But this is the function for the derivative of the cost function with respect to W, and this is it with respect to B. And so basically, if you're looking at this stuff, right, in NumPy, we load it up here. Doesn't that sound like a really cool keyboard, right?
Sounds like IBM.
You like this crap? Look at this. I bring my own keyboard because I'm really nerdy. So basically, this square thing that I showed you before, if you want to look at what this code looks like in Python, you can see that, well, this is, I don't want to do this one. This one's too complicated. Let me do a triple here. This is the one I wanted to do. Notice that when I'm training it, I'm basically doing a for loop over that thing that I just did. Well, there's the loss function, the square of h minus y mean, right? This is the accuracy. Remember, this looks weird, but I want the max index for the answer, not the number. This tells me how accurate I am. And then I print this out, and notice that when I update it, the gradient is that formula I said, and then I subtract off the learning rate times the gradient. This is basically it. If I run this, this is with the triples, right? If I run all of this, let me see if I can, it should be super fast, right? There it is. There it's drawing. This is still running. No, that finished already. This is the final, this is it's training it right now in the loop. I literally wrote that thing that I just showed you. It's looping through now. The loss is going down. The accuracy is going up. Do you see that? And then if I scroll all the way down, the final W for this one is not what we had before. Remember how I had 1s and 0s? But basically, this is mathematically equivalent. Right? This forces all of the ones on this side to go negative and sums the top 3. That's crazy, right? I basically wrote that thing that I showed you in like, how many lines of Python? Oh, whoops. Well, scary. How many lines of Python? Like 10?
You almost got taken by the matrix.
Yeah, that was crazy. I almost got eaten. Now let's do a prediction of this one. Boom, top. Well, let's do this. Let's make this 255. 255. Oh, that's too much. I don't want to blow it up, right? I mean, do you see it guessing? That was stupid, right? Basically, machine learning with deep learning is now stacking those things on top of each other. And then doing other crazy things called regularization to make sure that you're getting the right values, right? And then also doing some crazy things with pictures like convolutions, right? Or if you're using text, putting them in sequences. So that's the basic unit of all deep learning in a nutshell, right? And did I use any crazy machine learning frameworks to do that? I did not, because that's stupid. The more complicated ones are obviously more stupid, and so you have to use something a little more
What would be
complicated.
the prediction if you would put 255 on the top, on that example?
Oh, this one?
Yeah.
B, studie.
And if you run it again,
By the way,
but that's because of the beat, right?
there is no B. I don't think, oh yeah, probably because of the B. But here's the thing, this is what, I was like, oh, I did hit the B. I really thought of myself in the past. The past Seth was really nice to future Seth. I was like, no, I'm too stupid to do that. Oh wait, there it is, thank you. Yeah, so you're looking at this and you're like, this isn't exact, Seth. Yeah. That's machine learning. Right? And you're wondering, well, how do you get these numbers? I told you, there's a little Mario running around in that for loop trying to find where the bottom of that thing is. And then he found one that's close enough, right? And you can see that that's what it is. Now you're probably wondering, well, what the heck? It guessed top even though they're all, like what if I put 255 in all of them? What's going to happen then? Sorry, just kidding. No, that's not it. Right? It just gets top. Do I know why? No, I don't know. I mean, I guess I could go in there and look at the numbers. But the problem is that when you have a deep neural network, this matrix here, specifically when it comes to digits, is going to be 784 wide. How do you make sense of that? And that's the problem, I think, with deep learning. There's no computational learning theory behind it, which is okay, I guess. But. All right, so we learned how the things work. We did that thing. Did I go back all of a sudden? Oh, now what you can do is you can stack them, put functions in between them. By the way, if you just stack them the way I showed you, that's not neural networks. It's basically linear combinations of linear combinations are still linear combinations. You can prove that inductively. So you add a function in between called activation functions, and now these things are neural networks. Okay. All right, are we good with this? Now you know. Now the process of figuring all this stuff out is you have to choose the right architecture of neural network. You have to choose the right cost function. I showed you mean squared error, but there's others, right? Like binary cross entropy, a bunch of other ones. And then you have to choose, so it's the right model function, the right cost function, and then the right optimizer. Like the SGD that I showed you, stochastic gradient descent, that works sometimes, but others are better, like ADAM or RMS prop or others. So how do you know which ones to use for your data?
Science.
You use science. Thank you, sir. And as you know, science is a fancy way of saying, we're going to guess and see if it works. That's science, right? And that's why it's called data science. Okay? All right, so I did that. Let's talk about Azure Machine Learning Service, because now I want to get into the new stuff. So,
Seth, it's 8:31.
oh, am I over? Is it over?
I think it's done at 8:30.
Oh, shoot. Can I show you like one thing?
You can do it. I will allow it.
She's really in charge. It's not even true. It's not even. Here is the new workspace. You saw the cool automated ML things. Now you can keep track of all of your data sets, experiments, models, and endpoints. You can have shared compute, data stores, and node VMs. So as you do your sciencing, you can actually output stuff and see what people did over the lifespan of all your machine learning among all of your coworkers. Right? Because this kind of sciencing takes a long time, And if you have a super good data scientist like Sally, obviously Sally's going to get a new job, not at the bank, somewhere else, make tons of money. But then what do you do when the new data scientists come in and Sally had all her stuff on her hard drive that was wiped? That's why you do everything together.
You got
That's
the
how-
mailbox still.
What's that?
You got the mailbox.
Oh, yes. Yeah, you do.
It's a backup, right?
And so that's the Azure Machine Learning Service. For those that are wondering, you want to take 2 minutes and then we'll close. Because some of you are asking about this thing, right? This is still in there.
Yeah, so someone was asking about the old ML Studio. So it's still there, but it's now called Visual Interface. So we're redoing it. It's now integrated into the Azure Machine Learning Service that he was talking about. All right, Mike's. So what it is, for those that don't know, it's a visual interface that allows you to build machine learning models with this graphical UI. It kind of looks like a Visio diagram. And just give you a quick little tour of it. So someone was asking about data sets. There's a bunch of sample data sets that are already loaded into this. So if you spin up an Azure Machine Learning Service and you go into Visual Interface, you can come in here and just start playing with some sample data sets. And then if you go in here, you can see the different models that are available within it. You can do custom code within it. So if you want to use Python or R, you can execute that within it and do anything. If you want to use the pre-built functions, you can't do everything, but you can do a lot of like the basic solved questions that's what's talking about. So this is just a basic model where we're doing some time series forecasting to predict demand for a particular item for a store, so retail sales forecasting. It's a regression, so it's predicting a number. I won't go into too much detail since we're over time. Does anybody have any questions about visual interface or, yeah?
Can you also do automatic machine learning?
Auto machine learning? No, you would probably want to use the one that she
Okay.
showed.
Not
for
any
that.
visual interface.
Yeah.
Okay.
So this one is visual interface, that one's AutoML.
Yeah.
They're both graphical or I guess I would kind of say like no code, even though you can use code in visual interface. But they're both kind of graphical UIs to build models.
Yeah, so that's one way of doing it. Another way of doing it is actually, for example, and hopefully this loads up fast because it was slow earlier today. Basically, this is an example of me running that digits thing that I was showing you, but inside of Azure Machine Learning Service. Well, it might take a while. So I'll let it load up, and then you can see it a little bit later. Okay, so I believe I am out of time unless anyone has any questions. Explainable AI, unfortunately, I don't have time for, but I can show you. There's gonna be a video coming out about it, like next week or the week after. I'm not sure. Thank you so much. Hopefully this was helpful, and now you get a good sense for what's going on inside these things. They're not magical. Like, if you want, later I can open a file and show you. Basically, those things are in there, the numbers, the B's and W's. It's really not as mysterious as everyone thinks. And it's rather unfortunate that it's gotten to the point where people are like, well, like for example, and I feel bad, but take a look at this little thing. So I'm going to reveal this in Explorer, and I'm going to open an actual model file that this thing made. Are you ready? Like, this is the actual model that it output. And when you look at it, like I just had a 2-stack, and notice that there's the kernel. It's that matrix I told you about. Look at the size. And look, these are the numbers that it learned. Like, I don't know what else to say, but it basically learned more numbers on its own. That's a model.
Did you have a question?
Yes?
So your conclusion is that the visual interface is going to replace the Azure Machine Learning Studio.
Yes,
So
it
the
is.
studio will disappear in the future.
Eventually, yeah.
Okay.
Yep, and then it's in preview now, so we're still working on the visual interface, but yeah, eventually, Reunion Studio will be able to do a visual interface.
But all in the same place.
Yeah, it's
Okay.
really nice now that it's integrated into visual interface or that it's integrated into the service because the models and the experiments all are showing up in the back end. So if you're building with AutoML, you can share data sets as well. So the data set stuff she was showing, you could use that same data set in visual interface or in AutoML or in a custom experiment. So it's now all kind of integrated together into a
So the pipeline we supposed to use for the older Azure Machine Learning Studio, we still can use in the
Yes.
interface.
Yes.
Everything stays the same, even.
We will do the best we can to make it stay the same, yes.
How about the Azure Machine Learning Workbench?
That has now been integrated into Azure Machine Learning Service. altogether.
It's not integrated.
It is. If you looked at the data set stuff that she did, you saw some of the Workbench features in there.
Okay.
Yeah, you, like the little, you saw all the little, like when you loaded up the data, you saw all the histograms and stuff. That's kind of neat. But we'll talk afterwards. I want to make sure if people need to go, you can go. Thank you so much for your time. We really appreciate it.
Alright, some drinks in the hall, in case not everybody heard. Okay?
Hey, thank you so much for that demo. That was so good.
I love this video.
Yeah, that's true. All right, let me shut my stuff down here. Send me an email because I made this one special with this one, but I have those slides elsewhere that I give you. Just send me an email or reach out to me on Twitter. Because I have those in other presentations that are more complete. It's just my first name dot last name Seth.Juarez at Microsoft.com.
Yeah.
We use shortcuts. So, for example, if I go to the resource groups,
My pleasure.
here, for example. So, for example, if I'm here and I press Ctrl/, then it goes here.
All right, buddy, come on over. What's up?
Why is this organized? Because we use like a global AI community. So,
I just want to say something. So I haven't used this particular community. Like, I didn't use that particular points on it. It's like,
This is true.
Did it use to do that?
No, I just found out that I could use shortcuts. I tried to use them.
So it depends on what you want to do. So that's why, like, if you were to be like, hey Seth, I want to do machine learning and I want to use Python, I'd be like, hey, use Azure Machine Learning. Yes, that's what I like, but I'm biased. Yes, we're combining everything together in one umbrella. And you'll learn more about, I can't talk about it, but at Ignite, in our next conference, we'll tell you more. Does that work? Cheers.
So the next time we come to the dashboard.
I don't know, whenever I'm invited. So thank you for coming.
Yeah. Thank you for your advice.
Oh, thank you. Hey, do you have a question? Oh, thank you. Oh, cool.
But the way you explain it was like this.
Stupid.
No, it made it so much easier to explain because the professor was yeah, they explained it in a really different way, but the way you did it,
I don't know why they did that.
if you ever want to hear,
What's that? I know, but I showed calculus.
you just know how to do it.
yeah, it depends. We also just like
Yeah, I explain. I try to, like, when I put crazy math, I try to explain it.
Yeah, I passed with an A, but if you were my professor, I would probably graduate with
With a C minus tops.
should not be that. Just basically, it's
Oh, thank
really
you
nice
so
of
much.
explaining it, like makes it so much easier.
Thank you so much. Cheers. Thanks for coming. Let me know if you need anything, okay? Cheers. Oh, thank you so much for coming, man. Yeah, let's do it. Let's do it. Where? Good lighting. Oh, of course, of course.
So I was trying to use the new interface. And for the second one like this,
Of course.
a new data set. So I went
On social media.
and
Where was it? Is it both? Was it Tech Summit?
Well, I mean, it's not
That's right.
it's not there yet.
Well, dude, I'm glad you came back.
I think they're still like on that. It's always like and things like that are definitely feedback. But yeah, that seems like a basic thing. But the reason basic thing is that there is still being built. This literally went to public preview like maybe 2 years ago.
What's up, buddy?
So it's
Yes,
very
please.
it was just because I was really curious.
Thank you so much.
So that's like one thing about this is like you're basically doing testing, right? Like, Oh, yeah.
Oh, you are?
There.
Cool, let me know if you need help. I'm happy to provide you guys help.
I know,
But it's gonna be you, I won't be in it.
Submit things directly to, like, to get uploaded.
I can give you advice on where it's going, that way you're not
And when they
too
look
well off
on
the
them, they
rails.
update the
Kind of
status.
happy.
If somebody requests
Yeah, I think
and then you
it's going to
know,
get a little bit.
yeah.